Okay, good evening, folks. Here's what we're going to be talking about. First of all, we're talking about 6.5 multiplication of polynomials. Now, last week we talked about adding and subtracting, and when we added and subtracted, the exponents did not change at all. But with multiply and divide, exponents do change. Do change. So anything that was original is probably going to look completely different by the time we're done multiplying. So we're going to start off with something relatively easy. We've got a monomial, that is, it only has a number and a variable, and we're multiplying it by a polynomial. In this case, it has four terms: 4x cubed plus 5x squared minus 8x minus 10. Okay, what we're going to be doing here is the lovely distributive property. So I'm going to take 2x cubed and I'm going to multiply it by each of the four terms that I have there. So that means I am basically going to take 2x cubed times 4x cubed, and that 2 times 4 gives me 8. And when we learn the laws of exponents in 6.1 and 6.2, it says when you multiply the same bases, you actually add the exponents. So 3 plus 3 will give me a new exponent of 6. So notice that the exponent changed. Now I'm going to take 2x cubed and I'm going to multiply it by 5x squared. 2 times 5 will give me a positive 10. And then I have 3 x's here and 2 more here, which if I add 3 plus 2 gives me a grand total of 5. Next, I'm going to take 2x cubed times a negative 8x. Now remember, folks, subtraction signs are like superheroes. Sometimes they are mild-mannered, little unassuming subtraction signs. That's when we're looking at the whole equation, in this case, the whole polynomial. And other times they are the mighty superhero, if they need to stand out. When you're looking at an individual term, in this case 8x, this lovely sign right here is no longer the mild-mannered subtraction sign. It is now the powerful superhero negative sign. So 2 times a negative 8 will give me a negative 16. And I have 3 x's here, and there's an exponent here of 1. We don't bother writing it, but it is an exponent even though it's not there. So 3 plus 1 will give me an exponent of 4. And last but certainly not least, we're going to take 2x cubed and we're going to multiply it by a negative 10. So 2 times a negative 10 is negative 20. And there is no other variable here, so it's just going to stay at x cubed. So my final answer in this case is 8x to the 6th plus 10x to the 5th minus 16x to the 4th minus 20x to the 3rd. Now we did distributive properties earlier, but now we're adding in the variable, so that's what makes it different. Now, that was a monomial times a polynomial. Now we're going to get a little bit more complex. We're going to take, in this case, a binomial times a binomial. Depending on when you were in high school, whether it was a long time ago or just relatively recent, there's two different ways to set the problem up. We are going to be using the FOIL method, F-O-I-L. F stands for first, O stands for outside, I stands for inside, and L stands for last. So you can multiply it this way: first, outside, inside, and last. And another way to write it, and like I said, this is just another way to write it, it is doing the exact same thing, is what you might have heard of as the box method. The box method is simply, think back to the good old days of 3rd grade when you first learned about multiplication. You sometimes had multiplication grids. We had numbers over here. In this case, it's going to be 3x plus 4. And you had numbers along the top. In this case, it's going to be 2x minus 7. And what you did is you took the two things on the outside and you put them together and you multiplied it and put the answer in here. And lo and behold, it'll still end up being the FOIL method. Notice we're going to multiply the first numbers first, then we're going to do the outside numbers, then we're going to do the inside numbers, and then we're going to do the last. It doesn't matter whether you write it out this way and do it long ways or you put it in the box method. I really don't care. Which method you feel comfortable with is the method I'm happy with. So 3x times 2x will give us 6x squared. We multiply the 3 and the 2. We add the exponents. There's 1 and 1 gives us 2. 3x times a negative 7 will give us a negative 21x. 4 times 2x will give us 8x. And 4 times a negative 7 will give us negative 28. So we multiplied to fill the box, which is basically the distributive property. So like I said, it doesn't really matter. So now I've got 6x squared, I've got a negative 21x, I've got a positive 8x, and I got a negative 28. This is not completely done yet because I need to simplify by adding and subtracting like terms. Add, subtract like terms. Now, from the previous section, adding and subtracting, our exponents don't change. So x squared is going to stay x squared, x is going to stay x, x is going to stay x, this is going to stay a constant. Remember, this on here, or the FOIL, if you do it this way, exponents will change. When we combine like terms, they will not. Well, lo and behold, these two right here are like terms. Why are they like? Because they both have an x to the first power. Yeah, x squared is not considered alike with these things, even though they all have the same letter. It's kind of like red apples and green apples. They both might be apples, but you don't want to put them together. It's not going to taste well. So if I put them together, I get 6x squared. A negative 21 plus a positive 8 is going to give me a negative 13x. And then poor negative 28 on the end doesn't have a buddy either. So there is my final answer. 6x squared minus 13x minus 28. There is my final answer. So, next one. Ooh, this one's stepping up a little bit more. I got a binomial, there's 2 of them, times a trinomial, which is 3 of them. Same idea. It's a distributive property. It's still kind of FOIL if you want to call it. You can also make it a box method. And it's basically you're going to take 6x and multiply it by all 3 things in here. You're going to take a negative 2 and multiply it by all 3 things in there. So you should end up with 6 terms. 3 from when you multiply the first number, 3 when you multiply the second number, grand total is 6. Now, like I said, you can do a box method. I personally like box method just because it just takes up less space and it helps you keep organized a little bit better. So you don't accidentally forget something. So I got a 6x and I got a negative 2. And I'm going to multiply both of those by the x squared, the positive 5x, and the negative 3. I'll still end up 6 boxes. I'm still going to end up with 6 terms just like you will. So 6x times x squared is going to give me 6x to the third. Exponents change when we fill in this lovely box. 6x times 5x is going to give me 30x squared. I have 6x times a negative 3, and that's going to give me negative 18x. There's 3 terms out of 6. Negative 2 times x squared is negative 2x squared. Negative 2 times 5x is going to give me negative 10x. Negative 2 times negative 3 is going to give me a positive 6. So once again, we multiplied to fill the box. Exponents changed. Multiply to fill. Exponents change. Now, let's write out our lovely terms. Got a positive 30x squared and negative 18x, a negative 2x squared, a negative 10x, a plus 6. Okay, now we're going to combine terms by adding and subtracting. Once again, adding and subtracting, the exponents do not change. So poor 6x cubed doesn't have a partner, but the x squareds have a partner. Okay, positive 30x plus a negative 2x is going to give me a positive 28x squared. Positive 28x squared. And then I got a negative 18x and a negative 10x. If I add negative 18 plus a negative 10, I'm going to end up with a negative 28x. And then poor plus 6 doesn't have a partner either. final answer. 6x cubed plus 28x squared minus 28x plus 6. Okay, fabulous. Once again, I don't care whether you write it this way or if you write it out all 6 terms in a row, whatever. Trips your trigger, floats your boat, melts your butter, cranks your tractor, or flies your plane. Now, of course, we can't just leave it like that. We must step it up just a little bit more. You're going, oh my gosh, there are 3 binomials there. How do I do that? Well, it's going to be a 2-step process. We're going to take this and multiply this together first. We're going to take the answer from this lovely problem and we're going to multiply it with this one second. So we're basically going to do 2 FOIL methods or 2 box methods, whichever way you like to say it. So once again, I'm going to do it as the box because I like the box. I have an x plus 3 and I have an x plus 4. I'm going to multiply x times x will give me x squared. X times a positive 4 will give me 4x. 3x times x will give me 3x. Positive 3 and a positive 4 gives me positive 12. So x squared plus 4x plus 3x plus 12. Lo and behold, like terms. Right there in the middle. So x squared plus 7x plus 12. They're alike, once again, because they're both x to the firsts. Now, I'm going to take, here's my answer to the first 2. I'm going to take this lovely thing, and I'm going to multiply it with this. Okay? I'm going to take the answer that I just got, that trinomial, and I'm going to multiply it by that last binomial. So, once again, I like the box. The box is my friend. I'm going to put the 3 terms on top and the 2 along the bottom. So I got an x plus 5 left, and I came up with x squared plus 7x plus 12. That's what I did. That was the answer from the previous problem. Woohoo! Previous problem, went up there. So, x times x squared gives me x cubed. X times 7x will give me 7x squared. X times 12 will give me 12x. 5 times x squared will give me 5x squared. 5 times 7x will give me 35x. And 5 times 12 will give me 60. So I have x cubed plus 7x squared plus 12x plus 5x plus 35x plus 60. Ooh, sorry if I off the page for a moment. I'm going to back it, pull it out. Hopefully you guys don't get seasick. Now, I'm getting ready to add like terms, but I want you to notice one little thing. Back here in the original problem, oh, I had a minus 35 on the end. Since I'm in the home stretch, I'm going to take this minus 35 and I'm going to plop it down here on the end. Because I have, oops, sorry about that. I'm going to plop it down on the end because I'm pretty sure there is a like term that I can combine that 35 with. So it's very, very important when you have a problem like this, don't forget the thing on the end. It's very easy to forget, especially when you're doing XYZ or you're in a hurry or you're tired. You might want to highlight it or mark it or something so you don't accidentally forget it. But if you're doing XYZ and it told you you were wrong, and you know you did your multiplication right because you checked it, go back and check. Did you accidentally forget something on the end that you needed to add in? So, with that in mind, x cubed. There is no other x cubed there, so I'm just going to bring that bad boy on down. Oh, I'm sorry, I forgot my squared with my 5x squared. 5x squared. Ooh, look, I have x squareds that are the same. So, 5x squared and 7x squared add to give me 12x squared. I got a 12x and I got a 35x. Both are alike. 12x plus 35x gives me a grand total of 47x. And then looky, 60 and that negative 35 from back up here. Oh, look, they're alike. Why are they alike? They're alike in the fact that they don't have a variable with them. That's what makes them alike. So 60 plus a negative 35 should give me 25. And that is my lovely, lovely answer. I know it seems like a lot of work, but once you get the hang of this, it will go a lot quicker. Now, the length of a rectangle is 5 more than 3 times the width. Write an expression for the area. Write the expression. Here, I'll even put it in a different color. Write an expression. It did not ask us to solve it. It did not ask us to solve it. Only thing I'm basically creating is a formula. I know, isn't that wild? A formula. We're going to create one. Now, important things to know. Rectangle. Oh, look, a rectangle. When we're doing this lovely thing, you need one side to be the plane variable. Nothing more that you're going to do with it. So you got to ask yourself, just like when we were doing story problems, what do you have to know first in order to figure out the other side? Well, it says the length of a rectangle is 5 more than 3 times the width. So as soon as I know the width, I can do some fancy calculating and find the length. So I'm going to call W my width. Isn't that wild? Which means, according to this, the length is 5 more than, that means I'm going to add 5 to 3 times the width. 5 more than 3 times the width. Now, more than means that 5 is going to go last and 3 times W is going to go first. If you have a Monday moment and you put 5 plus 3W, you're in luck because addition is commutative. Commutative property means you can change the order and it's still the same thing. 2 plus 3 gets you the same answer as 3 plus 2. Isn't that nifty? So the next thing we need to know is, it says write an expression for the area. Area of a rectangle or any parallelogram at all is length times width. Length times width. In this case, the length is 3W plus 5, and the width is W. Area. Now all we have to do is simplify it. Well, in order to simplify it, it's kind of like the very first example. We just do a distributive property. You might be going, but it's at the end of it. How can we do that? It's okay. The operation between this parenthesis and this W is multiplication. We can still distribute it back. So in this case, our area is going to be 3W times W. There's nothing to change the 3, but the W, I add their exponents and end up with W squared. And then a positive 5 times W is going to give me, well, a positive 5W. And lo and behold, there's my answer. All it wanted to do is basically want me to give a formula, so that's what I did. So your homework is on section 6.5. It's page 144, numbers 1 through 35, every other odd. Don't forget to use your bookmark to help you out there. And then 41 through 65, every other odd again. And then 69 through 73. So your homework will be due the next time I see you in class, which in this case will be Wednesday. Hopefully this was very helpful to you. Have a good evening and stay tuned for the other 2 sections. Bye.